How do you measure the performance of an LLM? Answer: measuring the performance of a large language model (LLM) is crucial to evaluate its effectiveness and identify areas for improvement. Researchers and practitioners have developed various evaluation metrics to gauge the performance of an LLM. These metrics are task-specific, meaning they are designed to assess the model's performance on a particular task, such as language modeling, text classification, named entity recognition, machine translation, or summarization. One common metric used to measure the performance of an LLM is perplexity. Perplexity measures how well the model predicts a sample, commonly used in language modeling tasks. A low perplexity score indicates that the model is better at predicting the next word in a sequence, which is essential for tasks like language translation, text completion, and chatbots. For instance, if an LLM is tasked with predicting the next word in a sentence, a lower perplexity score would indicate that the model is more accurate in its predictions. Another important metric is accuracy, which is used for tasks like text classification to measure the proportion of correct predictions. Accuracy is a straightforward metric that calculates the number of correct predictions divided by the total number of predictions. A higher accuracy score indicates that the model is more accurate in its predictions. The phone score is a harmonic mean of precision and recall used for tasks like named entity recognition. The phone score provides a balanced view of both precision and recall, which is essential for tasks that require both accuracy and completeness. A higher phone score indicates that the model is more effective in identifying named entities. Blue bilingual evaluation and a study score is used to measure the quality of machine-generated text against reference translations commonly used in machine translation. The blue score calculates the number of matching and ground sequences of n words between the generated text and the reference translation. A higher blue score indicates that the model is more effective in generating high-quality translations. Rouge recall-oriented understudy for gisting evaluation is a set of metrics that evaluate the overlap between generated text and reference text, often used in summarization tasks. Rouge calculates the number of matching unigrams, bigrams, and trigrams between the generated text and the reference text. A higher Rouge score indicates that the model is more effective in generating summaries that are similar to the reference text. In conclusion, measuring the performance of an LLM is crucial to evaluate its effectiveness and identify areas for improvement. By using a combination of task-specific metrics, researchers and practitioners can gain insights into the strengths and weaknesses of an LLM and guide further improvements. These metrics provide a comprehensive view of the model's performance, enabling developers to refine and optimize the model for better results.